Thank you. Just before I start, is there anyone here who was responsible for the 2018 badge hardware? No. Okay. Shame, I would like to talk to you. Yeah, this is a project. When I was working on this, I put 2018. I realised I've been doing this for a bit longer. So, some expectations first. It's very much a one-dimensional radiotelescope. So more like the middle image, less like the right-hand image. We're not going to get a picture out of this. We're going to get a wavy line. If we're lucky, we'll get the whale signal. But graphs, not pictures. I realised my interest in Jupiter started in about 1990 when I upgraded telescopes. Blinded myself looking at the moon, and the next thing I found was Jupiter, and it was like vanishing out of the field of view very quickly. And I've sort of always been interested in Jupiter since then. And then, sometime around about 1992, I came across this book, the second. I actually read the Odyssey series out of order. I came across 2010 first before I read 2001. And there's a section in there talking about just the noise of deep space in orbit around Jupiter, and all they could really hear was the sound of lightning bolts and atmospheric noise. Later in the book it talks about there's possibly some of the sound coming from life on Jupiter. Bit far-fetched, but who knows. And again, for some reason this stuck with me. And then about 2 years later, a giant comet hit Jupiter, and there was suggestions that you may be able to hear the radio noise from the comet hitting Jupiter on a shortwave receiver. Certainly people had detected it. I just got my first shortwave receiver a couple of months before. That is it. It's in need of a bit of repair these days. It was probably 30 years old before I got it, so it's getting on a bit. So I set up the radio, simple dipole antenna for about 15 megahertz. I borrowed a chart recorder from my school, plugged it into the headphone socket and waited. I was digging in the archives and found the actual plot I took from this. This is about 2 hours. The arrow marks 7:30 AM UTC, when fragment G, which was the big one, hit Jupiter. You can see I didn't see anything, just baseline noise. What I didn't know at the time was Jupiter was below the horizon. It wouldn't even rise till after 1 PM, so I had no chance of seeing any signal from this. My enthusiasm outstripped my ability. That's not foreshadowing, is it? All I'm actually seeing here, looking at this with hindsight, is just drift on the plotter. I don't think I even had a signal going into the plotter. Some years later, I bought a better telescope and took my best picture to date of Jupiter. But we can't have nice things. Visual astronomy from the planet is pretty close to a bust these days, and we know who to blame for that. Sometime 2017 or early 2018, I must have been talking to somebody about what I tried to do in 1994. And I had a bit of a hunt around the internet, found the Radio Jove website, and sort of got a bit of interest in it again. The website's still around, doesn't seem to be updated so much, and they've moved away from simple receivers that they were doing in the early part of the century. Now everything's been done with SDR. So in early 2018, April 2018, I was on some other social network, which we don't talk about anymore, and was actually building a radio to receive Jupiter. I even put a small video up on YouTube, which is the screenshot over on the far side from me. It's a lash up at best. The green board in the middle on the left-hand image was some commercial radio receiver I was trying to modify. I've got a signal generator going into it for a local oscillator. I've got an STM32 on the display. It was a bit of a mess. For some reason, I didn't take it any further. I think I know the reason I didn't take that any further was I came to my first EMF and was handed one of these. you come here and someone hands you a programmable mobile phone. I got very enthusiastic about learning to program it. Never did manage to make a phone call on it. I think I did send a text from it at one point. And I decided this was, it's much neater than that. It's got buttons, it's got a screen, it's got audio in. I should be able to turn this into a Jupiter receiver. So when I got back, it sat in the box for a while, and then I started programming it, wrote a Mandelbrot fractal, realized you had to program it in Python, which not exactly a great fan of Python, but we'll get there. And then it sort of sat in the box until the call for participation for EMF 2026. And I thought, well, I fire off a proposal, don't expect to hear back. Yeah, let's see what we can do. Sun and Jupiter are strong radio sources. I've got a badge, which I know how to program. I did a fractal on it nearly 10 years ago. How hard can it be? I didn't expect to hear back. I actually didn't realise the theme this year was space. Well, maybe that helped the talk get selected. What's the worst that can happen? Well, the worst that can happen was it got chosen. I had leave to burn from work, so I took a week off work, thought, great, I'll work on this, get it done. It was 40 degrees in my workshop and I did nothing. Early in June, and this is a little bit more foreshadowing, I took a photo of Jupiter and Venus in the early sky. In the late evening sky. Jupiter's the higher bright point, Venus is the lower bright point. Planet Earth, the one we're on, is the lower bright points. So, with that in mind, Jupiter's up in the sky, it's dark. So I started building, a bit more recently I'd like to admit. Build a filter first, because if I can't filter out the rest of the junk that's in the radio spectrum, I'm not going to get very far. So, pretty good filter. It's never not funny to use SMA connectors on proto board. I mean, it's going in, perfect 50 ohm match straight into a knockoff Toco coil, which wasn't as well matched as it could be, but picked it up, actually got a pretty good plot of the filter. I like filters, so I did a second filter on the back end just to clean up the upstream end of the filter. Nice and narrow, centered on 20 megahertz. Band pass is about a meg, which is pretty good. Cleans things up. Well, if I've got a filter, I probably need a radio to go into. And my previous experience when I was building the system back in 2018, I was using a commercial board I was modifying. It was a double conversion super het. No one else is ever going to get another one of these boards. It just happened to be one I found randomly. So I thought, I'll try and build something I can document. If someone else wanted to at least try to build it, they could. So I scribbled out, back of a A4 envelope, simple NE602 direct conversion receiver, and then started soldering. It was an utter pig to get the local oscillator to work on this. You can see the black square and there's a crystal next to it. That's been moved around the board about 3 times, each time unsoldering and lifting pads off the back. Until I eventually got it in a place where I could guarantee it would start. Inter-pad capacitance was really screwing me up. Sensitivity was actually surprisingly good. I tested it on the bench at about minus 110 dB. Which is pretty good going. We've got 45 dB a gain roughly from the NE602. Had some audio gain on that. This is actually starting to look doable. So then I thought, well, I've got too much bandwidth. What I'm trying to do is look for a very small slice of the spectrum and just look at that. Because there's a load of other stations, there's a load of other noise and hash, around about 20 megahertz. I just want to look at a bit that's normally quiet and just look for peaks in the noise and hopefully associate those with astrophysical things. So I've simulated all these filters, actually built them, got them going quite well. So we've got a filter on the left, that's about 1 kilohertz band pass. I started doing that with an op amp. All it would do was oscillate. Gave up, just did it with inductors and capacitors. Rock solid, just works. And then I've got a bit of audio gain on the other side, and then just level shifting up so I can feed it into an ADC. If you think the front of the boards looks messy, you haven't seen the backs yet. They'll be on display in the Q&A tent if you want to laugh. Then I hit a problem about 2 weeks ago. For the life of me, I couldn't get audio working on the badge. No idea, just wouldn't go. Fired off a couple of messages to likely people, didn't hear back. Dug around through the source code for the badge. I mean, the badge is wonderfully documented. You can find the code for everything on there, and I've spent a lot of time hunting on that. So if I can't do that, if I can't get an audio signal into the badge, I'll just glue on an ADC. Luckily, on the front of the badge, there's a series of pin headers, which is an I2C bus. Great. All the code, everything you need to know how to test the badge is online, so you can figure out how to drive the port. Apart from one glaring omission, this is why I was hoping to be someone from the badge team who would know this. I couldn't find a GPIO pin on the front that was interrupt capable. So what I want to do is have the ADC, once it's finished the sample, generate an interrupt that the badge can then take, grab the data, do the processing. Otherwise, the badge has got to keep going, are you ready yet, are you ready yet, and just burn cycles. Hunted around on the schematic, I found one interrupt-capable pin I could access. The center pin of the joystick, I could tack a pin onto that. It does mean you have to unplug this when you first power the badge up, because the ADC holds the pin low or high, I can't remember, and it stops the badge booting, or it puts it into recovery mode. So we're back in progress. So all I've got to do is write some Python again. Python's easy, right? It works. Yeah. Tilde Tools, the software that supports this, is great but not great. I'm sorry I'm complaining about nearly 10-year-old software. I can get it to run code on the badge, but I can't upload code to the badge. It keeps complaining about missing docstring errors. I've taken code that I know is on the badge, downloaded it, re-uploaded that, and it worked. So I then took the code I downloaded from the badge, hex edited the header into my file, so I know it should be the same, all the docstrings there, re-uploaded it, still get docstring errors. So I ended up using Thonny as an IDE just to upload to the badge. That seemed to work. It doesn't appear in any of the menus because the docstrings are different, but it seems to go. You can't run the code in Thonny because it crashes, so you have to run the code from Tilde Tools and upload via Thonny. I got to the point I could write some code. So I thought, well, first thing I want to know, is Jupiter over the horizon? I don't want to have the same issue I had in 1994 and be listening and Jupiter's way down there. You know, I'm running late, running early. I revised my opinions on Python. Python's actually quite nice if you just want to write some fairly basic code to work out step by step where Jupiter is, where the sun is. It worked quite nicely. 3rd edition of Practical Astronomy with your calculator. There are libraries that can do this, but I thought I want to do this. I don't know how much space is actually left on the badge with all my upload attempts, because that's the other thing. I couldn't figure out how to delete from the badge. Had some help received as well. To do spectrum analysis, I plan to use, there was a free FFT library written in ARM assembly language. Well, it turns out the older MicroPython on the badge doesn't support inline assembly. So I put a shout out on Mastodon. Anybody got a quick and dirty FFT library, you can lend me, give me. 2 wonderful people, Zul and the doctor, came back with examples. I ended up using the one from Zul. It works very nicely. So I got the code lashed together, read the ADC, calculated an FFT, and plotted it. It's a bit noisy, to say the least. My neighbour had switched on something and just completely obliterated the fraction of the RF spectrum I was looking at. Then I looked outside. So I had a chat with a neighbour, they switched it off. But then I looked outside and thought, I wonder where Jupiter is these days. It's right next to the sun. The brightest source of RF noise and optical noise and radioactive noise in the solar system. In the time it had taken me to actually get going on this project, Jupiter is no longer an evening object. It's up there briefly, but it's pretty close to the sun the whole time. They set round about the same time. So what I actually have is about 4 hours of noise from the sun recorded on the badge. This is actual sun noise. I've checked this several different ways. The other problem with the badge, which I'm still working on, it's quite small. I can get about an hour's worth of plot on it's 320 by 240, I think, display. I really want to record several hours. So what I did was told the badge, plot it, but also give it to me over the USB port, and I replotted it. The same data, the same FFT data is plotted just in GNU plot, and then replotted up there. I can see the sun. I can see a general baseline noise. The two horizontal lines are interference from a very narrowband station, but the general yellow trend on there is noise from an astrophysical source. I did a correlation with an SDR receiver in the shed at the other end of the garden, and that was not seeing, well, that was seeing wider noise, which was coming from sort of commercial stations. Doing a bit of subtraction. This is astrophysical noise. So I hit a bit of a problem at the moment in actually trying to listen to Jupiter. My enthusiasm has got the better of me, or my inability to follow a time schedule has got the worse of me. So now I've had to postpone my planning until December. Then Jupiter finally moves far enough away from the sun, and I should get about 4 to 6 hours of observation per night, depending on how high Jupiter is in the sky. So maybe I'll be back to tell you how well it worked in 2 years' time. I've still got some to-dos. There's things I need to work on for this. I think I'm going to move the ADC code and the FFT code to a separate micro. I'll leave the badge just as display and comms only. That way I can just connect to the I2C port, have the badge just request data from a separate micro. I'll add a GPS module to the badge for timing and position, because the code that's calculating where Jupiter and the sun is needs reasonably accurate time and data. And I'll be adding an antenna switch to periodically just switch in a dummy load, just so I can calibrate out system noise. Last thing I need to do is actually write this up. It will come up on webshed.org in the very near future. I haven't had a chance to put a cover page up yet for this project. So yeah, it's taken longer than I thought it would. I didn't realise I'd still be working on a project I started in 1994 in 2026. Yeah, time blindness can be a thing. And with that, I think I'm done, which means I'm very early. Thank you.